common security threat to databases is something called SQL injection. SQL injection happens when a program, such as a web page or a database procedure, is expecting a value. And maybe that value should be a simple value, like the number 22, or the state NJ for New Jersey. But instead of getting a simple value, these programs get in something malicious. They get in a value, but then they get in extra SQL statements. And these extra SQL statements are injected into the program that processes it. Now, the good news for us is that SQL injection is an old exploit. It can still happen, but using good modern security practices, you can overcome it. These practices include in PHP, using PHP PDO and binding parameters to SQL calls. They include double checking your inputs to make sure there's nothing malicious in those. And through a combination of these procedures, you can pretty much stop SQL injection cold. But in this lesson, I'd like to show you some of the ways you can use SQL injection to really inflict malicious harm on a database. SQL injection attacks play out in two stages typically. In stage one, the attacker is trying to submit different values for arguments, and they're trying to observe how the application responds and determine an attack to attempt. Then, after they've done the research, they provide carefully crafted input, usually containing some embedded SQL, that will be interpreted as a command rather than just data. And then the database will execute the command as modified by the attacker. Anytime you have something called dynamic SQL, which is SQL that is driven by parameters that are passed to the program, that type of SQL statement is very vulnerable to injection. There's a great site in W3 Schools you can look at to see an example of SQL injection, and that is listed below in the hyperlink. Okay, so here we're going to exploit a PHP page that creates dynamic SQL. And the way it does it is you pass it in an actor ID. The program will take that actor ID as input. It will create a SQL statement that will find all the movies that that actor starred in. So let's take a look. Normally this would be a form with a text box where you would type in the value 2. But we'll click this hyperlink and we'll see how the PHP works. These are all the movies in the database that feature actor number 2. And you can see it's just a pretty normal select statement that gives us back 3 columns. The movie's ID, title, description, and release year. Now that we know this, though, we can try to see if this PHP is vulnerable to SQL injection. So what we're going to do is our second hyperlink here, where we're going to type a 2 into the text box, but we're not going to stop at the 2. We're going to say 2 union select 1, 2, 3, 4. What we're trying to do is we're trying to inject extra SQL into this PHP file. And when we do so, you can see now what the select statement looks like. It added the union to what was selected first. And if we scroll to the bottom, why yes, there is 1, 2, 3, and 4. So obviously this SQL worked, which means that I can feed it not just a regular value like the number 2, but I could feed it SQL statements as well. Okay, good. Now that we know this, let's try to union something more exciting than 1, 2, 3, 4. Let's union a query that's going to get information about my entire database schema. So here, instead of querying 1, 2, 3, 4, I'm going to query the information schema of my SQL. And I want to know the table schema, the table name, the table rows, and the update time. Just a little bit of information. And when I try to run this SQL injection, I still get the films for actor 2, but look, I'm getting extra fields from my information schema. And I can look and say, okay, I can see all of these things. And if I scroll all the way down, I can see what my tables are. So I see here there's an actor table and a film table and a film actor table. I also see there's a customer table. That's interesting. I wonder if the customer table has any proprietary information. So suddenly now I'm aware of the entire schema of my SQL, and now I can start to mine even further. So if I data mine down here, I am going to look at this particular table, and I've added more SQL in here, and now look what I get. I get the customer table and the fields. The customer ID, which is int, the first name, the last name, the phone. Oh, hit the jackpot. I get the card type and a card number. So I can maybe get credit card information from the customer table. Now I know the name of the table, and I know the fields of the table. So I should be able to put those to some malicious use. So now I am going to start my first query. I'm going to union again, but this time I'm going to select fields from the customer table. And when I do this, and I scroll to the bottom, I see, there's Mary Lewis and there's Dan Steely, and I could get their phone numbers. Okay, but I know every single column in the customer table, so I can run a variation of that query down here. And now if I scroll, I'm going to get their address. Okay, so that's helpful. And then finally, I'm going to come down here and get their credit card information. And there is Lewis, and that's their Visa number. And here is Steely, and that's their Visa number. And suddenly, I've been able to take a simple movie query application and go someplace else. Go to the customer table and actually steal credit card numbers. Here's something else that's pretty dangerous. Here's another form. This form updates a movie, and if I click on it, I can update movie 29 and show you how this works. It's updating the film, it's setting a title to something, description to something, etc. And it's also updating the film category. So it's running two different update statements as one. It's updating a film's description and title, and also its category, like is it drama or is it horror? Fine, but that's dangerous because I can now use this to do other things. Now that I know that this takes in more than one update statement, I can try to do different types of statements, not updates. So remember when I looked at this schema before, I found this very important table. Let me show you what was in it. It had one message. This is a very important table. Hope nobody drops it. Okay. Now, what I can do is I can do a denial of service attack, and I can drop that table. And so notice here I have a URL, but at the end of the URL, I am going to say the film ID is 29. That's what I'm updating. And then I have this drop table, right in the middle of all of this. And when I do this, I update the movie and I give it all this new information, but I've also dropped the table. Now if I query it, nothing there. That's because I have this drop table, a very important table, embedded right inside of my value that I'm sending to the PHP file. All right, let me restore it so we can try something else. Now I've restored the table, and I can query it again, and it does have its original message back into it. Fine. Now let's try a delete. I can do a delete statement. Here again, look, film ID is 29. That's what I'm updating. And I could have passed it more parameters as well. Then I have the semicolon and delete from a very important table. And when I do this, it updates the movie, but it also deletes that table. And when I query it again, you'll see, yeah, nothing there. The table is now deleted. So let me restore it. All right, let's query that table again, and we can see that we brought it back to its original state. So if you run an attack and you drop a table, that's disastrous. If you delete everything from a table, that's disastrous. And that's going to trigger your DBA to probably go to the backup tapes to restore something. It's an obvious, very brutal attack. But something that's more subtle could be an update attack. So instead of dropping the table or deleting the table, you can just change one row of the table. That's pretty insidious and pretty hard to determine. So if I click on this now, this is another hyperlink, only now it's going to update the table. And when I query it again, it says haha. So I could change numbers, I could do all kinds of things that would not be detected. So you've lost a lot of the data integrity. So these are some examples of injection attacks. SQL injection can happen in more than just web pages though. Here's an example of someone who was trying to be secure. They created a view called student view. They removed all the proprietary columns, all the confidential columns are gone. And so when you select from that, all you can see is that information. The student ID, first name, last name, major, minor, matriculation year, and whether they're a transfer. And they thought they were being clever. They built a procedure to help do some analysis, some aggregate queries. And in that procedure, you could pass in certain columns. And if you passed in certain columns, it would analyze the GPA based on certain factors. And so you can see that they're expecting col 1 and col 2 to be sent in as parameters. But because it just takes those parameters and plops them into the SQL, you could call the procedure with using functions. So I can call it using the length of the first name. I never would have expected to use that to aggregate my data, but I'm tricking the system, passing it in a function, and then is transfer, because I know that ed is not a transfer. And then I can see, oh, wait a second, for anyone whose first name is only 2 characters, I can see that the average GPA is 2.5, the min is 2.5, the max is 2.5. And since Ed Chase has a first name of length 2, I now know Ed's GPA, even though it was only available to me in the aggregate. By aggregating over something weird, like the length of your first name, I was able to get lucky and find out Ed's GPA. So this is an example of SQL injection because I'm passing more than we wanted into that procedure. It's also an example of an inference attack. What we should do is not just take in col 1 and col 2 as inputs to this procedure. Rather, we should validate that they are in fact the fields that we want to expose to the end users and not just take whatever they give us. So this is SQL injection, taking perfectly good dynamic SQL statements that accept parameters and changing those parameters to do malicious things.